Now we are talking about the present value yesterday. Now this is the present value of an annuity. Means if we are paying a certain sum, what is the value of that particular sum to us after a certain period of time. Previous day we are talking about this formula, present value of an immediate annuity. We are on this slide and this is the formulation of that particular slide. And previous day we are just talking about what is present value, what is the second installment value, what is the final installment value, and so on and so on. So then we have, and the first installment B is equal to A by 1 plus I plus A by 1 plus I whole square plus A by 1 plus I whole cube plus dot 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 plus A by, this is the last time, A by 1 plus I whole to the power n. Therefore, P is equal to A by I into 1 minus 1 by 1. It will be plus I whole to the power of m. I repeat, and there is a mistake in that particular book. It will be 1 plus I to the power of m. Now, amount of annuity due at the end of the period. Amount of annuity due at the end of the period. As defined earlier, annuity due is an annuity in which payments are made at the beginning of each period. The first installment will earn interest for n periods. At the end of I% per period, similarly, second interest installment will earn interest for n minus 1 periods. As was said previously, that when you're providing the first installment will earn interest for you are paying a 6 months installment for a mobile phone. The first installment will earn interest for 5 months. The second for 4 months. The third for 3 months. The fourth for 2 months. The fifth for 1 month. And the final installment will be only the amount of the principal. So we have this formula, normal formula for annuity. We had done two problems previously, yesterday. A is equal to 1 plus I into A by I, within brackets 1 plus I whole to the power of n minus 1. This is the formula. For the first, we have A into 1 plus I whole to the power of n. For the next, we have A plus 1 plus I whole to the power of n minus 1. For the last, we have A plus I1 to the power n to the plus A plus I1 to 1 by I to the power n minus n. That is A. Now we have A, the total formula is A is equal to 1 plus I, A by I into 1 plus I whole to the power of n minus 1. This is the formula we need. This is the sum that we had done the other day. Here A is equal to 64,000, n is equal to 2, and I is equal to 24,000. We had done this from the previous day, and the principal amount is 64,000. The question is find the total annuity if the principal amount is 64,000, n is 2 years, and the rate of interest I is equal to 12 by 100 is 12%. We have ordinary annuity A is equal to A by I into 1 plus I whole to the power of n minus 1. That means we have A is equal to 64,000 divided by 0.1 whole multiplied by 1 plus 0.1 to the power of 12 minus 1, or is equal to 64,000 into 1.1 to the power of 12 minus 1 is equal to 3.1384. Now ordinary annuity is equal to 6. Now 1.1 to the power of 12 is equal to 3.1384. Now we have 1.1 to the power of 12 minus 1. So we have the value of this one, particularly here, is the value of 1.1 to the power of. Now, this, as you can see from the our calculators, if we have 1.1 to the power 12 is equal to 3.1384. That is 1.1 to the power of 12 is equal to 3.1384. Now this minus 1 is 2.8531, 2.1384 into 6,40,000. That gives us 13,68,000. 300. Now is the second question. We also did that yesterday. If the payment of rupees 820,000 is made quarterly for 10 years at the rate of 8% per annum, find amount of the ordinary annuity. Now we have A is equal to 20,000. The previous problem was similarly like this, but here is a difference in that at 10 years at the rate of 10%. Now here we have a small problem over here. In the previous problem, we had this I and we did not have a K because the interest was paid annually. Now in this problem, the interest is paid quarterly, that is 4 times a year. So we have N into K. If A is equal to 20,000, N is equal to 10, K is equal to 4, 10 years, N is equal to 10, K is equal to 4, and rate of interest is 0.0. Since we have the payment is made more than once in a year, so the lower denominator, that is A by I, in this particular formula, A by I is replaced by A divided by I by K, or 1 plus I by K. It was 1 plus I, as we can see, 1 plus I inside. It is 1 plus I by K, repeatedly 1 plus I. We can see here 1 plus I. We have replaced it by 1 plus I by K in this portion, 1 plus I by K to the power of N into K, N into K to the power of N into K, this portion. Previously, it was only N. Here, this portion is only N, and now it is N into K, this portion, minus 1. So it is replaced by I by K, and N is replaced by N into K. Then we have 20,000 divided by 0.2. This is 8% divided by 4, that is 0.2, 2%. So N by K, the inner portion will also be 1 plus I by K, that is 8 by 4, that is 1 plus 0.02, but it will be N into K, it will be 40 times into minus 1. So 10 lakhs into 1.02 to the power of 40 minus 1. So 1.02 to the power of 40, we get 1.02 to the power 40. It gives us 2.2080 or 2.208 minus 1. So we have 10 lakhs into 1.208. That is, we have the value equal to 12 lakh 8,000. Now this is the total value of the annuity. Now we have another sum. I'll be sending these sums over the net. Now we have a man deposit. I believe we have done this sum. Man deposits rupees 30,000 on 31st December 1996. What amount does he receive on 31st December 2008 if the interest is 10% compounded annually? We have done two sums like that. Now this is one of them. If A is equal to 30,000, I is equal to 10 by 100 or 10%. I have only given one sum. N is equal to 12 years. A is equal to A by I into 1 plus I whole to the power of N minus 1. So we just substitute as we had done the previous day. That is 30,000 divided by 0.1 into 1.1 to the power of 12 minus 1. That is equal to 3 lakhs into 1.1 to the power of 12 minus 1. So A we have as 3.1391 because 1.1 to the power of 12, 1.1 to the power of 12 is 3.1384 or 1391 as depending on if you take a log, if you use direct calculator, minus 1. So the answer will be 2.1391 into 3 lakhs or 6 lakhs 41,780. Remember, you get a little bit of answers depending on whether you're using 3.13 or 3.1391, but that does not necessarily matter. This is all for the day. Thank you.